I would like to welcome you to this Developing Fraction Sense 3 and 4 introductory webinar, and this is Dr. Henry Borenson presenting the webinar. If there should be any technical issues, they're quickly resolved, so please stay where you are. The question is, why don't students hit a home run in their work with fractions? And the answer is they never get to first base. So what do we mean by that? Let me give you an example. In one of the National Assessment of Educational Progress studies, this is a national sample of fourth graders were asked which of these fractions is closest to a half. And only 25% of those students could answer this question. Now notice that you could easily eliminate 1/5 and 1/6 because they're very small. You can eliminate 2 halves because they're 1. So if nothing else, by a process of elimination, the students should have known that it's 5/8, and yet only 1/4 of the students could do that, which shows you that when you talk about fractions with students, very often they have no idea what these symbols mean. So we would like our students to become experts in working with fractions, but they cannot skip the basics. So the question is, what instructional strategies can we use that will be helpful? So we have a full day workshop available at 6 hours that focuses on the grades 3 and 4 standards. And there we go through the material slowly. The participants have a chance to work at their seats to make presentations at the front of the room. Here in 45 minutes, I can only give you a taste of that full day workshop, but also hopefully you'll have some ideas or strategies that you can use maybe beginning tomorrow. So the first part of the webinar will focus on concepts that are in the Developing Fractions Sense Student Workbook A. So we're going to get started. So the students have these plastic fraction blocks, and you say to them, please place the red blocks on the yellow block. And if the yellow block is a whole, what fractional part is each of the red blocks? So the students see that 2 of them fit the yellow block, so they know that each one is a half. So then you ask them to explain, how do you know that each one is a half? So very often, students will say, well, each red block is a half because there are 2 parts. There are 2 of them, and the 2 parts make up the whole. Now, I hope you understand that that answer is not satisfactory. If the students keep that answer in mind, they are going to end up having difficulties. Why? Because look here. Here you have 2 parts that make up the whole, but each part is not a half. And so therefore, we have to be more specific in our use of language. We have to say if a whole is partitioned or broken up into 2 equal parts, each part is called a half. Okay, so we need to mention a whole, we need to mention partition, and we need to mention equal parts. And we have the following notation. We write if y equals 1, if the yellow block is 1 or a whole, or the red block is a half. And then you say the same thing to them. Please place the blue blocks on the yellow blocks. They do that. They see that 3 of them make up the whole. And you ask them how much is each one, and they'll say that each one is a third because the whole has been broken up into 3 equal parts. So if y equals 1, b is a third. And likewise with the green blocks, there are 6 of them. And so the red block, once we know that the yellow block is 1, the red is a half, the blue is a third, and the green is a 6. Now, what you could do is you have these blocks in your hand and you put up the blue. How much is the blue? How much is the red? The blue, the green, the blue. And in 1 or 2 minutes, at most, the kids will know if the yellow block is 1, what the other pieces are. They'll know because they have different colors and they have different shapes. So in my experience, there's nothing that compares with working with these fraction blocks when you introduce concepts related to fractions at all grade levels. Now, A unit fraction is one part when a whole is partitioned into equal parts. So therefore, each one blue block, one red, or one green block, they are all unit fractions. They are one part when a whole is partitioned into equal parts. Once students know what a unit fraction is, they're ready to begin understanding what a fraction is. So, for example, the fraction 3/6 is the quantity formed by having three parts of size 1/6 referring to the same whole. So these last few words are critical, because if you have 1/6 of the Empire State Building, 1/6 of a small house, etc., that's not 3/6. You have to have reference to the same whole. And so in order to fix that situation, we use this language. 3/6 is or are three copies of 1/6, because when you have a copy of something, you're maintaining the same size. So this language is very common today. 3/6 is three copies of 1/6. This language assures that we are speaking about the same whole. So the students are now ready to do some of the exercises in the workbook. Now, the red booklet that you saw has some 35 lessons. A number of them take 5, 10, or 15 minutes to do. So this one in lesson 4, the students need to name each fraction. So the yellow block is 1. Would you please text chat, what is the name of this fraction? Remember that the green block was a 6. Would you text chat the name of this fraction, please, the one in the middle? So what you would do is you would count the number of blocks, and you would see that the answer is 5/6. How about this one over here? What is the name of this fraction? Remember that the blue part is a third. So this one here, the one at the end, what fraction is it? It's going to be 4/3. Now notice that 4/3 is more than a whole. 5/6 is less than a whole. Okay, so those are the answers to that. Now, in the red booklet and in the workshop, we deal with fraction blocks, rectangular grids, and number lines. In other words, we want the students to have a strong concept related to fractions, and we use these three different approaches. So when we ask students what fraction of the rectangular grid is shaded, we expect them to count or to figure out the number of boxes altogether, which there are 20. 4 are shaded, so we expect the answer to be 4/20. We don't expect the answer of 1/5 because we have not yet spoken about equivalent fractions. We'll do that a little bit later. And also with line segments. So in lesson 8, the students have to name the length of this line segment. Now, the way they do that is this. They look at the segment from 0 to 1, and they see that that segment is partitioned into 1, 2, 3, 4 equal parts. 1 part, 2 parts, 3 parts, 4 parts, and therefore each small segment is 1/4. So now they simply count how many red segments there are here. 1, 2, 3, 4, 5. And so the answer we would expect and that most students would give would be 5/4, because each small segment is 1/4. Now, of the three models, the number line is the most abstract and the most difficult for students. Now, this is lesson 8 here. So we have skipped a number of the introductory lessons before students can do what I just showed you. They're also asked in lesson 10 to locate the points here. So for example, to locate 4/5, so the segment from 0 to 1 is broken up into 5 parts, 1, 2, 3, 4, 5. So we would expect them to know that this point is 4/5, this point is 5/5, and this point is 9/5. These may seem like very simple elementary exercises, but you'd be surprised without instruction that students would have tremendous problem doing these exercises. Okay. And the red book comes with the answer keys available with it. Okay. So now we get to equivalent fractions. So equivalent fractions is part of the third grade standards. However, we go beyond what's expected. So first of all, we defined two fractions are equivalent if they are the same size. So then we asked the students to do a problem like this. 1/2 is equal to how many 6? So we help the students to understand the problem. We say to them, how do we represent 1/2? And they'll say a red block. How do we represent the 6? They'll say a green block. So we say, okay, this problem is asking us how many green blocks, how many 6 are equal to a red block. So once you phrase the problem that way, they take out their blocks. By this point, by the way, some students will know that mentally. So they'll see that 3/6 is equal to 1/2. So notice that we did not solve this problem by giving the students some kind of mechanical rule that they don't understand. We don't expect that in the 3rd grade. Rather, we want them to actually see that two fractions are equivalent concretely. And then we could go on in lesson 13 to give them a problem like this. So this problem is not part of the regular 3rd grade standards, but since we're using concrete materials, there's no reason why we can't ask our students to do this. So the approach is the same. 3/2 are going to be 3 red blocks. So the students take out their blocks and they figure it out. Now what's going to happen is this, and they're going to get the answer of 9/6. But what's going to happen is this. Some students, once they set up 1 red equal 3 green, they won't have to set up the others. They'll just mentally know that if you triple the red, you're going to triple this. So when you give this problem to their students, I think I've seen 4 or 5 different approaches that students use to get the answer of 9. Now, those of you who are using hands-on equations will notice that the approach we are using here is very similar to the approach in hands-on equations. Namely, we have an abstract equation or problem. We model it with the concrete materials. We solve it using the concrete materials, and then we answer the abstract equation. So this is the learning system we are using. Now, how would you use the above images to determine the missing number? So in lesson 14, the students are given these images and they're supposed to answer this question. 2/4 are how many 8s? 3/4 are how many 8s? So what we would want them to do is this. We see that 1/4, which is a long blue block, is equal to 2 8s, which are 2 squares. And therefore, 2/4 would be 2 of these long blocks, and therefore that would be equal to 4 8s. 3/4 would be 3 of these, so that would be equal to 6 8, and 4/4 would be equal to 8 8. Okay, so we want the students to use the actual concrete or pictorial images to figure out these problems. And notice that as they're doing that, they're reinforcing the idea that an 8 is smaller than a 4th, right? That's taking place automatically. In the 3rd grade, students also need to learn fractions equivalent to whole numbers. So, for example, 2/2 are a whole, 3/3 are a whole, 6/6 is a whole. So what pattern do you see? And then we extend this pattern using rectangular grids. So what patterns do you see? That when the numerator and denominator are the same, the fraction is equal to 1. It turns out that this idea that n over n equals 1, 5/5 equals 1, 4/4 equals 1 is a very powerful concept. With this idea alone, students can do a tremendous amount of work with fractions, adding fractions, subtracting fractions. It's amazing the power of this little principle. In the 3rd grade standards, the students also need to be able to compare the size of unit fractions. Now, this is lesson 27. The first time you give a problem like this to your students, insert the correct symbol, less than, equal, or greater. almost automatically they'll say that 1/3 is less because they see that the 6 is bigger than 3. So they'll do that without thinking just because they notice the 6 and 3. When you ask them to take out their fraction blocks, they'll see that 1/3 is greater than a 6. So if you give them a couple of examples, then we can generalize, or you can get them to generalize that in comparing to unit fractions, the one with the smaller denominator is larger. Remember, unit fraction has a 1 in the numerator. These are unit fractions. The one with the smaller denominator is larger. Okay, so now we consider the relative size of two fractions with the same numerator, such as 2/3 and 2/6. So you let the students work with that a little bit. They take out their blocks, and then you ask someone to explain for the group. This is lesson 30. So the idea is that if one blue block is larger than a green block, two blue blocks will be larger than two green blocks. Okay, so 2/3 is larger than 2/6. And so we could summarize that if two fractions have the same numerator, the one with the smaller denominator is larger. Now, the red booklet has 5 enrichment lessons, and it's a very good idea to give one of those enrichment lessons after every 7 lessons of the red booklet. It serves as a nice reward motivator. They like the enrichment lessons because it goes into more advanced concepts. For example, enrichment lesson 1 talks about other blocks as the whole. So, for example, if the blue block is the whole, how much is the green block? Please text chat your response. If the blue block is the whole, what is the green block? So the green block will be a half. 2 of these green blocks fit on the third. So we write if B equals 1, G is a half. How about if R equals 1? What is 2G? If R equals 1, what equals 2? How much is 2G? The answer is 2/3. Okay. Now, I am working with a 6th grader now, and she was able to answer this. Now, at this point, I haven't determined if she's specially gifted or not, but I was surprised that she could answer this question very quickly. Okay, so if R equals 1, 2G is 2/3. Okay, this is a good time to get some feedback. Are we presenting strategies that are valuable to you? You should be interested, let me change that, in implementing this program with your students. So can we have some feedback, please? Okay, what do you like about what we're showing you? Any special comments that you have? We've talked about unit fractions, we talked about fractions, the rectangular grids, equivalent fractions, other blocks as the whole. So the idea in grade 3 is to enable the students to understand what a unit fraction is and what a fraction is. And believe it or not, that's enough for grade 3. Okay, here are some comments. I think that fractions are so abstract, and it is great to see something that brings it down to the concrete. Thank you, Jenny. I already tried teaching lesson number 1, and surprisingly, my students had my 3rd and 4th. And let me see if I read that. I already tried teaching lesson 1, and surprisingly, my students had difficulty identifying the last problem. Okay, very good. So that's the idea. You want them to know that a fraction could be, okay, good. Excellent comment, good. The blocks are easy to see the difference between the fractions. Exactly. Some people like Cuisenaire blocks, but you have to understand, when you have rectangular pieces of different lengths, I mean, you know, the blocks are very easy to work with. you could do so many things with the blocks right away. Amanda, I think this would help my students learn better. I know I learn better when I'm given an opportunity to learn hands-on and with manipulatives. I know I need to go back and rephrase. Okay, good. Okay, thank you for those comments. Very good. Okay, so now, with your permission, I'm going to go on to the blue booklet. Now, whereas the red booklet, many lessons are 5 to 15 minutes, and I was recently in Florida, and a teacher told me she did 3 lessons sometimes in one day. The blue booklet is now more advanced, and so those lessons probably are going to take 15 to 30 minutes each. I don't think too many of them will be 5 or 10 minutes in the blue booklet. Now, notice we call it Workbook B, even though it focuses on the 4th grade standards. The reason for that is we want these booklets to be used by any students, even middle school students, who have had trouble with fractions. That's why we don't call it 3rd, 3, 4, and 5. Okay, so the workbook can be used where it is needed. Okay. So in the 4th grade, we talk about addition of fractions with the same denominator. Different denominators don't come in until the 5th grade. So what we do is this. We say to the students, how much is 3/6 plus 2/6? So notice, first of all, the difference. Instead of giving the students a rule for adding fractions, we say to them, please take out your fraction blocks. Show me 3/6. Show me 2/6. What do you have altogether? Well, 3/6 are 3 green blocks. 2/6 are 2 green blocks. What do I have altogether? I have 5 green blocks. I don't have blocks of another color, another size. So the answer of 3/6 plus 2/6 is obviously 5/6. So notice how this approach can eliminate this kind of common error. And when you see this error, you know that the students have no idea what they're doing when they're working with fractions. So you have to go way back to the beginning. So in lesson 6 of the blue booklet, they have examples such as this. Insert equal or not equal to make the statement true. For example, let's look at the first one. Is it equal or not equal? Okay, I'll have to get to some of those questions later. The first example, would you insert equal or not equal? Okay, so the students will add on the left. They could do it with their blocks, or after a while, they'll do it mentally. This is 4/6, and this is 4/6. How about the second one, equal or not equal? The second one will be not equal. So these are very simple exercises, but very basic exercises. Okay, so these are the types of problems you have on lesson 6. Benchmarks is an important part of the grade 4 standards. Now, when you and I were in school, we didn't have benchmarks. At least I don't recall a discussion of benchmarks. But today, it is a key area. And I'll touch upon it here. In our workshops, it takes up, I would say, maybe 45 minutes of the workshop. So first of all, students need to know that given a fraction, we can tell instantly if it's less than 1 or more than 1 by comparing the numerator to the denominator. If the numerator is less than the denominator, such as in 2/3, the fraction is less than 1. If the numerator equals the denominator, the fraction is equal to 1. And if the numerator is greater than the denominator, the fraction is greater than 1. Okay, so that's something that you establish in lesson 7, and there are exercises for them to reinforce that idea. Then in lesson 8, the students have to use a benchmark to compare these two fractions, and they have to insert less than, equal, or greater. So please look at this for a few seconds and then give me your answer. You're going to write less than, equal, or greater. What is your response, please? Less than, equal, or greater. 2/3 versus 5/4. Okay, so we're going to say that 2/3 is going to be less than 5/4 because remember, 2/3 is going to be less than 1, right? The numerator is smaller than the denominator, whereas 5/4 is greater than 1. So in Lesson 8, students compare fractions, one of which is smaller than the benchmark of 1, and the other one greater than the benchmark of 1. So 2/3 is less than 1, since 3/3 is equal to 1. 5/4 is greater than 1, since 4/4 equal to 1. Since 2/3 is less than 1, and 5/4 is greater than 1, we get that 2/3 is less than 5/4. And we can also justify that visually. If this is a whole, notice that 2/3 is much smaller than 5/4. Okay, how about this one? Less than, equal to, or greater. Please text chat your response. Less, equal, or greater. 1 plus a third versus 1 plus a sixth. Okay, so the answer to this problem is to realize that they both have a 1. So all you really need to know is which is greater, 1/3 or 1/6. And in 3rd grade, we learned that a third is greater than a sixth. So therefore, 1 and 1/3 would be greater. Since a third is greater than a sixth, 1 plus a third will be greater than 1 plus a sixth. The more that is added to a number, the greater the result. As in hands-on equations, each lesson has one new concept. So first, the students do problems such as this, 1 plus a third versus 1 plus a sixth. In the next lesson, they put that together, 5/4 versus 4/3. Okay, so now they have to realize that 5/4 is 1 plus a fourth, and that 4/3 is 1 plus a third. Okay, what's your answer here? Less than, equal, or greater? 5/4 versus 4/3. Five-fourths is another name for 1 plus a fourth. 4/3 is another name for 1 plus a third. So the answer is going to be less. Why? Because 1/4 is less than 1/3. Okay, so that's lesson 14. So in lesson 14, the students are comparing two fractions which are both greater than 1 by a unit fraction. Now, in lesson 11, the students work with the benchmark of a half. Notice that when the numerator is less than half of the denominator, the fraction is less than 1/2. 3/8 is less than a half. 4/6 is more than a half because the numerator is more than half the denominator. So this is lesson 15 now. So now we're working with the benchmark of a half. So this is a little more difficult. But certainly not impossible and certainly within their ability to do. So I'll give you a few seconds, please. Less than, equal, or greater. Less than, equal, or greater. Okay, I'm getting the answer of less. So let's see, half of 7 is 3.5. So 3 is less than that. Half of 9 is 4.5. So this is more than that. It looks like the answer is going to be less. Very good. Congratulations. Okay. On YouTube, if you search for developing fraction sense videos, you'll find some 18 or so videos of the students using the fraction sense approach. Now, how about adding mixed fractions with the same denominator? So again, we ask the students to take out their fraction blocks. They take out a yellow and 2 blue, another yellow and 2 blue, and they put it all together. This is lesson 20 now. So here's 1 2/3 plus 1 2/3. Notice what happens. Either the students on their own will form another whole, or you say to them, can you make another whole from the blue blocks? And the answer is yes. So the answer is 3 1/3. Now, please notice how similar this is going to be to the approach we use when we do this symbolically using arithmetic. There, we're going to take 3/3 and we're going to make another hole, just like here we take 3 blue blocks and we make another hole. So in lesson 20, they do this with the blocks. In lesson 21, they do it using arithmetic. They add the whole number parts, they add the fractional parts, and they get 3 1/3. Okay, let's look at subtraction of fractions with the same denominator. So we begin with something like this. And we ask the students to take out their fraction blocks. This is lesson 21. So here you have 2 1/3, and they need to take out 2/3. So we say, so at this point, the students have to think a little bit. Why? Because we need to take 2/3 or 2 blue blocks, and we don't have it here. We don't have any. So there are a number of approaches that students will use. The approach that we will be discussing is the approach whereby we exchange a yellow block for 3 blue blocks. In other words, 2 1/3 can be expressed this way. And now you can subtract 2/3 and you get the answer of 1 2/3. So notice what we did here. What we did is we renamed 2 1/3 as 1 4/3. We borrowed one whole from the 2. We exchanged it for 3/3. So notice how similar this approach is to one of the approaches we'll be using in subtracting fractions. So that's lesson 21. Okay. Now, in one of the following lessons, they have to use arithmetic to find the difference. So one approach could be, let's rename 3 2/6 as 2 8/6. But before we have the students do that abstractly, we want them to do it concretely. So in lesson number 25, the students convert mixed fractions to mixed improper fractions. Okay, this is new terminology. 3 2/6 is a mixed fraction. 2 8/6 is a mixed improper fraction because 8/6 is improper. Notice here you have 3 2/6. Here you have 2 8/6. So now what you're doing is you're not just giving them a rule, but you actually, the students are able to see and experience that this process produces an equivalent fraction. Now, once they've done that concretely, then they can do the symbolic solution. 3 2/6 is the same as 2 8/6, and you can subtract, okay? So that's one approach to subtracting fractions. Borrow and exchange, okay. Before we show the students how to convert a mixed fraction into an improper fraction, we have them use the fraction block. So here you have 2 1/3, and as you can see, that's the same thing as 7/3. Later on, they're going to be solving this because they're going to know that each whole has 3/3. So in 2, you're going to have 3/3 and 3/3 and 1/3, so that'll be 7/3. So this is lesson 29. And so now they can subtract these fractions by changing this to 26 minus 11/6. This is lesson 30. But notice we don't give them a rule. 3 times 6 is 18 plus 2. We don't do that. We just expect the students to know that one whole is 6/6. So altogether you have 11/6. We expect the students to know that one whole is 6/6. Remember that fundamental comment I made earlier? So you have 18/6 and 2/6. That way the students don't have to try to memorize a procedure each time. Okay, thank you, Amanda. We'll send you a link to the recording. Thank you for joining us. Okay, let me show you now the Borenson approach. I'm Dr. Borenson. Let me show you the Borenson approach, okay? Here we go, new approach to subtracting fractions. Ready? Tell me how you like it. The first thing we're going to do is we're going to change the problem. We're going to ignore the 2/6. Please text chat the answer. How much is 3 take away 1 and 5/6? How much is 3 wholes take away 1 and 5/6? Please text chat give me an answer via the chat panel. If you take away 1 and 5/6 from 3, what is left? Okay, I'm starting to get some answers. Take away 1 and 5/6 from 3. What is left? Okay, so you can either visualize 3 wholes and you take away 1 and 5/6, you'll see that you have 1 and 1/6 left. So the first step is you ignore the fractional component. Then in the next step, since you ignored it, you have to now bring it in. So the answer is not going to be 1 and 1/6, it's going to be 1 and 3/6, or 1 1/2. So the answer is going to be 1 and 3/6, or 1 and 1/2. So again, notice what we did. In order to subtract 1 and 5/6 from 3 and 2/6, we subtracted 1 and 5/6 from 3, and then we added 2/6. If you were able to follow that quick presentation and you like it, please text chat, I like it. If you didn't follow, you'll have the video where you could go over it more slowly, okay? A very nice way of subtracting fractions. And notice that in this approach, you don't have to borrow a whole, exchange it, make it in, it's a very direct and simple way. This approach is not in the 4th grade workbook, but it is in the 5th grade book that's under development. Okay, another standard in the 4th grade is multiplication of a fraction by a whole number. So previously we said that 3/6 are 1/6 plus 1/6 plus 1/6. Now we learn another way to express 3 copies of 1/6 using the multiplication symbol. So 3/6 are 3 times 1/6. So this is just a short way of writing 1/6 plus 1/6 plus 1/6. So now we want the students to show or to prove that 4 times 2/6 equal 8/6. Now this is different than the way we learned it in school. When we were in school, we were given a rule, but the students can figure this out because they take out 2/6, which is 2 green blocks, and they make 4 sets of those. So let's do that. 2/6, 2/6, 4 times. This is 4 times 2/6. And if you spread those out, it's the same thing as 8 times 1/6. So 4 times 2/6 is the same as 8 copies of 1/6, which is 8/6. Okay, I think this is our last problem for today. If a train travels 1 2/3 miles per minute, what distance does it travel in 3 minutes? Write an equation to represent the problem. Okay, the students use a letter. For example, let's say D be the total distance traveled. So D would be 3 times 2 1/3. The 3 is on the outside. The 3 is the operator. 3 times 2 1/3. And then the students can use their fraction blocks to see that the answer is 5. Okay, so this concludes the instructional portion of the webinar, and we do have a raffle coming up, so if you could stay with us, that would be great. These plastic blocks are very attractive to the kids. They look like jewels. They're just more elegant, but you certainly can use the wooden blocks. That's fine too. Are there additional practice pages? The time distance problems are intimidating, and the use of the blocks helps to see it and helps students become more comfortable. Okay, thank you, Jenny. Beyond the student workbook. No, we don't have any additional worksheets, but once you have the student workbook, you can come up with additional problems. Maybe at some point, if there's a need for that, we'll develop that. Right now, we don't have that. My son avoids fractions and always changes them to decimals. I think this will help him see. Yeah, to me, decimals are more scary. If he can do decimals, he's to be congratulated. Okay, very good. Okay, so let's go on. So we could finish on time. We have the full day Developing Fraction Sense workshop for grades 3 and 4. If you're interested, let your district know about it. We have the Making Algebra Child's Play workshop We have the Demystifying Verbal Problems workshop. We have a class set of Developing Fraction Sense. This is for 30 students. That's the price. Grade 4 for 30 students. That's the price.